Interpret a rhythm strip. What we are looking for is the pathologically in the form of an arrhythmias. Even so-called normal rhythms or heart rates can be cause for concern. Always look at the trend of a rhythm strip. Comparing the present rhythm strip to any previous rhythm strips paint a better picture of what the patient's condition is. This is the whole reason why it's very important to learn how to interpret rhythm strips. Especially when we have someone who has had a previous heart attack, or maybe they just had some mild heart palpitations. We need to compare their EKG, know how to compare their EKG strips from the previous one when they had the problem till possibly a current one to see if there's any changes that have happened. There are 5 steps in interpreting an EKG strip. First, we're going to ask ourselves 5 different questions. The first question we always ask ourselves is, are there any QRS complexes? The reason why we ask if there's any QRS complexes is because QRS complexes signify ventricular activity. If we don't see any QRS complexes, 9 out of 10, that means they have a what? Their heart is not contracting, or their ventricles are not contracting, therefore there is no heartbeat. QRSs signify ventricular rhythms. Once we have established that we have QRSs, our next question we're going to ask ourselves while looking at a rhythm strip is this rhythm regular but interrupted, or is it irregular? That is very important to know those aspects. Once we figure out what our regularity is of that EKG strip, our next question we're going to ask is, what is the heart rate? And of course, as you know, we cannot base heart rate without regularity because it forms different ways to calculate it, as we learned in chapter 5. So if we have a regular rhythm, we know we're going to use the 1500 method. If we have a irregular rhythm or irregular regularity, we know we're going to use the 6-second method along with the 1500 method to get our heart rate range. Once we figure out our heart rate, our next step is to say, are there any P waves? For a normal functioning heart, your heartbeat is functioning at its normacy. For every QRS, there precedes a P wave. That's why it's called a PQRS T wave. So are there any P waves? Yes or no? Once we establish if there's any P waves, the next step we go to is what is the PR and the QRS intervals? Well, if we know we have a P wave, therefore we have a PR interval. And of course, we already established we have QRS complexes, so we know that we have a QRS complex. Now, the difference is between when they ask you, are there any QRS complexes, they're asking if you actually see a QRS wave. When they say the QRS interval, that's a calculation. They want to know how many seconds did it take for that QRS to form. Take a look. What is normal? Well, we know normal is if it follows the true normal conduction flow of the heart, meaning it goes from the sinus node down to the AV node, from the AV node down to the bundle of hairs, to the bundle of hairs to the right and left bundle branches, and the last electrical output is sent through the Purkinje fibers. That is a normal functioning rhythm. Those types of rhythms we call sinus rhythms because they're normal rhythms, because the SA node is the boss pacemaker. He's the boss of your heart. He's the one that's supposed to send the signal out for electrical impulse to conduct in your heart. That's why we call it sinus rhythms. Sinus rhythms have narrow QRS complexes of uniform shape, meaning they all look like British shoulders and they all form equally the same. They look the same throughout the whole 6-second rhythm strip. There's no deviation. They're regularly spaced QRS, meaning they're in a flow. They trudging along like a choo-choo train. A sinus rhythm usually has a heart rate between 60 and 100 beats per minute because it is normal. It will always have upright rounded P waves that are married to the QRS. Your PR interval will be anywhere between 0.12 to 0.20 seconds, and it's consistent throughout every beat, meaning you can take your PR interval at the beginning, the middle, or the end, and they'll all be the same because they're consistent. Same goes for your QRS. Your QRS interval has to be less than or equal to 0.12 seconds. Arrhythmias. Arrhythmias are abnormal heart rhythms that can have a combination of different things. They can have a QRS complex that's absent or abnormally shaped, meaning your QRS, instead of being pretty and narrow, it might be wide and bizarre, or it might not be there at all. You'll just have a P wave with no QRS attached to it. Sometimes you'll have a QRS, but you won't have a P because the P has disappeared or is absent. Or you have a lot of P's. You might have PPQRS, or you might have PPPQRS, or your P might become, you might have QRS TP. It might be right after the T, and then you'll have another P. So that means your P's are abnormally shaped. They can be absent, or they can be multiple numbers, or different in different areas of the rhythm strip, because normally it's supposed to precede the QRS, be before the QRS. You can also, what makes an arrhythmia, you can have an abnormally short or prolonged PR interval, meaning your PR interval is right up next to, there's really no space, like your P is sitting right on top of your QRS, or your P is a long ways away from your QRS. It's like a faulty starter. You started and then it finally, after a while it'll rev up, but you just turn in the key and there's dead silence, and then all of a sudden you get a vroom. That's what we describe as a prolonged PR interval. Abnormally prolonged QRS intervals, meaning you have a wide QRS or wide and bizarre QRS, so therefore it makes your normal QRS wider than it was supposed to be. Heart rates that are abnormally slow or fast, meaning your heart rate is below 60 beats per minute, or it can be above 100 beats per minute. You will also have an irregular rhythm, or a rhythm that's interrupted by either a premature beat or a pause. This is what we call arrhythmias, due to abnormal circumstances of what's going on in the 6-second rhythm strip. Also, another thing that makes an arrhythmia is your heart rate can be abnormally slow or fast. So let's practice the 5 steps on how to interpret a rhythm strip. Note how the following characteristics and attributes follow. The first question we're going to ask ourselves are, first and foremost, are there any QRS complexes? Secondly, we're going to determine our rhythm strip's regularity. Third, we're going to figure out our heart rate. Fourth, we're going to see if there's any P waves. Next, we're going to figure out our PR and our QRS intervals. Now, remember, when you're figuring out your QRS and your PR and your QRS intervals, remember you're counting from the beginning of P to just before your Q wave dips down. You're counting the number of small blocks there are in between those two factors, and you're multiplying that by 0.04 seconds. Always to remember, once you finish calculating, that you always put seconds behind it, because if you give me an answer, you can have 0.44 and I'm be like, what, apples, millimeters, centimeters, seconds? Same thing when you're determining heart rate. Always remember to put BPM at the end of everything. Same thing with QRS complex. It goes from the beginning of your Q to the end of your S, meaning right at your J point just before your T wave forms. And as we go through these examples, rhythm strips that we're about to go through, I will show you what we're looking for. I'm not going to be the best drawer because I'm horrible at drawing on a computer, even with a pen, but I will try my best. At our first rhythm strip. Now, you're saying there's two. Whenever you see a two-line rhythm strip where it says lead 1 and lead 2, you take the best rhythm that you can possibly see a PQRST in it, which just happens to be our top rhythm. So lead 2 happens to be our best choice because we can see our P, our Q, R, S, and our T. So I'm going to write in red, dark red, light red so you can see. All right, so the first question we have to ask ourselves is, are there any QRS complexes? Well, yes, QRS, 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 QRS. So yes, we have QRXs. So what is the rhythm's regularity? Well, we have to go find our R to R intervals first, right? So we're going to go from R to R and figure out how many little blocks. Oops, I told you I couldn't draw straight. Using this, how many little blocks we have in between each R to R. I think this is safer for me to do it this way. Right, so R to R. Alright, so we have 5 here, and 5 here. So it's 5, 10, 15. Then we have 1 here. It's 20 and 21. So the first R to R interval is 21. The next one is, we have 5 here, 5 here, and not quite 5. 1, 2, 3, 4. We have 4 here, and 1, 2, 3. Remember, we're going at the top of your rhythm strip. And then we have 3 here. It's a horrible 3. So that's 5, 10, 14, 15, 16, 17. Here we have 5, 10, 15, 16, 17. 5, 10, 15, 16, 17. Oh, I can't count. I know what y'all saying. Oh, Miss Tina. Sorry, 17 here too. 17, 5, 10, 15, 16, 17. 5, 10, 11, 12, 13, 14, 15, 16, 17. 5, 10, 15, 16, 16, 17. 5, 10, 12, 13, 14, 15, 16, 17. So it's 17 straight across. So we would say this rhythm is regular, right? So we know we have a regular rhythm. So regularity is regular. So we determine that the rhythm is regular, that its regularity is regular. Now we have to calculate our heart rate. So we know since we have a regular rate, we're going to use the little block method or the 1500 block method. They both mean the same. So we're going to 1500 divided by 17, and that equals 88, because we don't round up. Your heart doesn't round. So this person's heart is beating at 88 beats per minute. So our next question asks, now that we determined, so let's go back through 1 through 3 question. First question says, are there any QRS complexes? We have established, yes, there are QRS complexes, and that they are the same shape. Yes, they are. We determine next one is the rhythm regular but interrupted, or irregular? We determine that this particular rhythm's regularity is regular. Once we determine that, our next step is, what is the heart rate? We determine that the heart rate is 88 beats per minute. So our next question, question 4, asks, are there P waves? Yes, there are P waves. I'm going to circle those in blue. There's a P wave here, a P wave here, a P wave here, and a P wave here, 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 and here. Okay. Yes, we have P waves. Are there any relationship to the QRS? Yes, they are married to the QRS. For every P, there is a visible QRS. Next, we have question 5 asks, what are the PR interval and QRS interval? So let's just erase our little circles off of the P's right quick. And let's find a good PR interval. Alright, so remember, if we have a regular strip, doesn't matter where we obtain our PR interval, because remember, it's consistent. So even if we go from the beginning, the middle, or the end and find our PR interval, It should all be the same throughout, because why? For every P that pulses out, your QRS will pulse out at the same time throughout a regular rhythm strip. So let's take this particular P right here. So we're going to go from the beginning of P, which is here, to just before QRS. Now this one just happens to have an understood Q, and the interpretation says PR interval is the beginning of P R Q. PRR. So right here. Let's see. I can draw a better line than this. This is a horrible line. Let's see. Right here. Nope, nope, nope. Right here. Okay. Okay, so this is our PR interval right here. This is what we call a PRI, or PR interval. And it's right here. So we're going to calculate this. It's 1, 2, 3. We have 3 little blocks. So we're going to say 3 times 0.04, and that equals, and this is for our PR interval, or our PRI. So we have 3 little blocks, and we're going to times that by 0.04. So 3 times 0.04 equals 0.12. And don't forget to add seconds. So our PR interval ends up on this particular rhythm strip to equal 0.12, which falls into normal range, because remember, PR interval's normal range is anywhere from 0.12 to 0.20 seconds. So once we establish our PR interval, our next one we have to figure out is our QRS interval. And I think I'm going to do that one in purple so we can tell. Now, maybe not purple. Let's try this green. So, starts at the beginning of Q, which we already have, which is the end of our PR interval. So we're going from here, where our PR interval left off at, and we're going all the way, so that's Q, R, S, and just where this point is, right here. Y'all see where this point is? Let's take the pen off. Just where this point is, what we call the J point, is where we're going to draw our line to signify the end of our PQRST wave. Okay, so this right here is what we call our QRS interval. And I'm going to just put I. So we're going to count the number of squares that is from here to here. 1, 2. We don't count halves because it just makes it more complicated. We're just learning the basics. So we have 2 squares from here to here. So we're going to go 2. So 2 times 0.04, and that equals 0.08 seconds. And this is our QRS interval. All right. Let's do one more example. We're going to go here. Let's go back to our red pen. So we're going to ask ourselves the same question. Are there any QRSs? Yes. But there's one trick. Are all of them uniformly shaped? No. All are uniformly shaped except 1, 2, 3, 4, 5, except the 5th beat. All are uniformly shaped except the 5th beat. All right, so we just established that we do have QRSs and that our 5th beat is abnormal. So next question we're going to ask ourselves is, what is our rhythm's regularity? Correct? Correct. So let's determine what is the regularity of this particular rhythm strip. So we'll go do our R-to-R intervals. R, 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 2, R. All right, so we have 5, 10, 15, 16, 17, 18, 19, 20. So the first R-to-R interval is 20 little blocks wide. Our next one is 5, 10, 15, 20, because our R stops here, and 21. Then this one is 5, 10, 15, 21. So far it looks like a regular beat till we get to here probably. 5, 6. So we're going at the top of this one, right? So we have 5, 6, 7, 8, 9, 10, 11, and 12. So this particular R-to-R is 12. So this one is 5, 10, 15, 20, 25, 26, 27, 28, 29. This one is 29. I know I can write this a little better than this. 29. And this one is 5, 10, 15, 21. So What this rhythm is doing is, being that it has this premature beat that's right here, and then it goes to 29, right? 5, 10, 15, 20, 25, 26, 8, 29. And then it goes back to 21, meaning it's going back to regularity. We would say this is regular with, or interrupted with, or interrupted by, but we're going to do shorthand, regular with a premature beat. Regular with a premature beat. Okay, so we determine regularity as regular with a premature beat. Now, as we know, going back to chapter 5, that if it's regular with a premature beat, we still calculate it as a regular rhythm, correct? So therefore, we would use the 1500 method. So we would go 1500 divided by 20, because we're just going to go with the first interval, and that would give us 1500 divided by 20, which gives us 75 beats per minute. All right, so next we have to ask ourselves, are there any P waves? Well, let's see. Are there any P waves? Let's circle those in purple. Let's see if it shows up. Well, there's a P wave here. 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 There is QRS T, a little P here, a P here, and a P here. So yes, we do have P waves. For every P, there is a preceding QRS. So we do have P waves. So next we have to figure out our PR interval, correct? PRI, our PR interval. So I'm going to erase this little duty here. And we're going to go in blue. So remember, we go from the beginning of P, which is here. Miss Tina can draw a straight line. There we go. To the beginning of QRR. So we have an understood Q, so we're going here. And I should draw this in red so you can see it a lot better. There we go. Well, let's do this in red so you can see. Come on, draw straight. I need a straight line. Oh, it erased the whole line. No. here to here. And from the beginning of P is here to here. That is our PR interval. So we have 1, 2, 3 little blocks. So we're going to go 3 times 0.04, which equals 0.12 seconds. So our PR interval is within normal range because it still falls into that 0.12 to 0.20 seconds. Next, we're going to figure out our QRS. So our QRS interval. Which we're going to go from here let's chart this a little better. We're going to go from here to RS, and just before it deflects up to do our T, which is here, which is in the middle of a block. So we have, if I were to draw my line straight, 2 blocks. 2 times 0.04, which gives us 0.08 seconds. All right. All right, so that is the second example. Now there will be flashing across 3 more examples, and if you're still having trouble with understanding, I can go back through this PowerPoint and finish out and give you the next